So in this question, we have blocks 1 and 2 connected by a light spring over negligible mass, string, and no friction in the pulley. Two different materials, A and B. Two-block system is released from rest, so we have a V0 equals 0, which we would expect. The speed begins to increase. When it reaches B, its speed increases at a greater rate. So there's an acceleration here, and this acceleration is greater. Well, the reason acceleration is greater is because there's less friction. And since the force of friction is mu times the force normal stays the same. So if the friction decreases, that means the mu decreases. So mu B is less than mu A. That's the first thing we should see. All right, so which of the following compares the coefficient of mu? All right, so we've already actually kind of anticipated that's what the question is about. So mu B is less than A. So A is greater than B. That looks like that could be right. A is greater than B. That could be right. No. B is greater than A. No. So we're at 50-50 for just recognizing that there's less friction during B. And now they want to know, the second part is, what about the net force acting on block 2? So let's draw what's happening with block 2. All right, so when it's in A, we have a force of gravity, the weight on 2. And there is a force of friction due to the material A. Now, when it's in B, the force of gravity acting on 2 is the same. But the force of friction is less at B. So when we draw our net force, we have a net force like this for A. And we look at B, we have a bigger net force because this force of friction and this force of friction at the other end, that force of friction takes up most of that. So we have a smaller net force. So the net force on A is less. The net force on B is more. Why? Because there is less friction resisting gravity. So gravity gets to dominate more. And so the net force, when it goes from A into B, increases.